Hello, in this video we will learn about cache mapping. There are three types of cache mapping. First one is direct mapping, second one is fully associate, and the third type is k-way set associative.
Let's discuss first what is cache mapping. In computer organization, the CPU is directly connected to cache, and the cache is directly connected to RAM. And RAM is connected to hard disk as shown in figure. All data is stored in hard disk.
Let's learn direct mapping first. The easiest technique used for mapping is known as direct mapping. The direct mapping maps every block of the main memory into only a single possible cache line. In simpler words, in the case of direct mapping, we assign every memory block to a certain line in the cache.
What is direct mapping? In the case of direct mapping, a certain block of main memory would be able to map to only a particular line of cache. Here, the line number of the cache to which any given block can map is basically given by this. Cache line number is equal to the block address of the main memory modulo total number of lines present in the cache.
W1, W2, W3 are words main memory contains for our example 32 blocks from 0 to 31. Each block contains 4 words, hence for 32 blocks we have 128 words. Cache memory contains lines from L0 to L3 which contains blocks of main memory which are frequently used. It is a small amount of faster, more expensive memory used to improve the performance of recently or frequently accessed data. Cached data is stored temporarily in an accessible storage media that's local to the cache client and separate from the main storage. Cache is commonly used by the Central Processing Unit, CPU, applications, web browsers and operating systems.
What is fully associative mapping? The fully associative mapping helps us resolve the issue related to conflict misses. It means that any block of the main memory can easily come in a line of cache memory. Here, for instance, B0 can easily come in L1, L2, L3, and L4. Also, the case would be similar for all the other blocks. This way, the chances of a cache hit increase a lot. Physical address: since the main memory has a size of 128 words, a total of 7 bits would be used for representing the main memory. Thus, the physical address would be 7 bits in size. Given below is an example of the fully associative mapping of W24 of the B6.
K-way set associative mapping is a combination of direct plus associative mapping, where blocks are placed according to the formula of K mod n and lines are divided into K parts by formula, total lines by K, and blocks are mapped to cache as shown in figure. So according to formula, L0, L1 contain blocks B0, B2, B4, B2n and so on, and L2, L3 can contain any blocks like B1, B3, B5. In cache memory for two-way set associative cache is divided into 2 parts. For four-way set associative cache is divided into 4 parts, so blocks will be placed according to formula, K mod n, individually in cache memory.